Today we're working on lesson 4.4a. As you can see from the title of the lesson, it's titled 10.2. That's because this is a review of Algebra 1 and how to simplify radical expressions. Alright, the key to doing this today is recognizing your prime numbers. You've got to break everything into primes. Now your prime numbers that you'll be using for the most part, 2 is the first prime, 3 is a prime, 4 is not because it can be divided by 2. 5 is a prime, 6 is not because you can divide it by 2 and 3. 7 is a prime, 8 is not, 9 is not, 10 is not, 11 is a prime, 12 is not, 13 is a prime, 14 is not, 15 is not, 16 is not, 17 is, 18 is not, and 19 is. And that should get you through today's lesson for your prime numbers. Okay, when we're looking at radical expressions, radical expression contains radicals such as a square root. All right? Now, the expression under the radical sign is called the radicand. Radicand is in simplest form if the following three conditions are true. No radicands have perfect square factors other than 1. No radicands contain fractions. No radicals appear in the denominator of a fraction. And we will be using these properties today to simplify the square roots, the product property of square roots. Tomorrow we'll move on to fractions. So today we're just doing the simple ones. Okay, we've got to simplify the square root of 80. Step 1, we need to factor 80 into its prime factors. The easiest way to do this is to use a factor tree. We're going to break 80 apart into two numbers that we know we can multiply to get 80, such as 4 times 20. That will give us 80. Now 4 is not a prime number, so you can see that by this list. 4 is not a prime number, so we need to break it down further. 4 is 2 times 2. Now we know that 2 is a prime number. It's from the prime number list. So I'll go ahead and circle those. Now let's do the same with 20. We're done with the 4s. Let's jump to 20. Okay, 20, I always think 4 times 5. Now, 4 is not a prime number, so we'll break that apart into 2 times 2, which are prime numbers, and 5 is a prime number. So, when I'm looking at this, the square root of 80 is equal to the square root of 2 times 2. Let me move that there. We've got 2 times 2 times 2 times 2 times 5. So, 2 times 2 times 2 times 2 times 5. Now the way I teach this basically is that when you've got a pair of numbers such as a pair of 2's, cross them out, the pair, and bring out a single 2. Likewise here, I've got another pair of 2's, cross those out, and bring out one single 2. Okay. Now, 5 does not have a pair, so it's going to remain in the radical. And that will lead, now what I'll do now is multiply what's outside. If there were more than just the 5 inside, I'd multiply what was left inside. And so, a simplified the square root of 80 is 4 root 5. Moving on. Okay, on this one, when we take a look at the product property, just like we broke this apart right here, the 80, into all of its different factors. What we can do by the product property of square roots is that when I have something like, let's say I've got the square root of 4 times 9, I could think of that as break it apart and the square root of 4 times the square root of 9, just like they've done right here in this one. I'm going to use that property here on our next example. Okay, so what I do here is I'm going to go ahead and take the square root of 2 times the square root of 14. Now, I'm going to combine all of that into one radical. 2 is a prime number, so that's going to go under the radical. 14, on the other hand, when I break it apart, it's 2 times 7, which are both prime numbers. I'll place those under the radical as well. Just like before now, when I can cross out a pair of numbers, I bring out one number. left inside the radical is a single 7. And so, the square root of 2 times the square root of 14 is equal to 2 square root 7. All right, now we're going to throw some variables into the function, into the mix here. All right, consider the expression, the square root of x squared. It may seem that x equals the square root of x squared, but when finding the principal square root of an expression, principal means positive square root, you have to be sure that the result is not negative. Okay, so what they're saying here is think about what if x were equal to negative 3. Okay, then the question is the square root of x squared equal to x? Well, the square root of negative 3 squared equals the square root of 9 because negative 3 times negative 3 is 9, and the square root of 9 is 3. On the other hand, remember we have substituted in a negative 3 for this, so x is negative 3. What you get right here is a false statement. Now how do we take care of that? Well, what we do is that when we have a, I have to explain here. Okay, notice in the case, if the right-hand side of the equation were the square of the absolute value of x, the equation would be true. For expressions where the exponent of the variable inside a radical is even, so the power is even, and the simplified exponent is odd, in other words, this was the first power, we need to use the absolute value signs to make it true. So even, odd, absolute value. Odd, no, I don't need to use absolute value. Even, no absolute value is necessary here. And even, odd, I need to use the absolute value. It's very important that you pay attention to that when you're working through problems here. So with this one, I'm going to go ahead and do the same thing that I did before. Step 1, I need to break 90 apart into its prime factorization. Now thinking of 90, I could think of 3 times 30 or 2 times 45. There's various numbers you could use here. 3 is a prime number. Now 30, I think of 3 times 10. You could also think of 6 times 5. It'll work out the same way. Okay, 3 is a prime number. 10 is 2 times 5. Those are both prime numbers. So I'm going back to this expression over here, the square root of 90 x to the third, y to the fourth, z to the fifth, and now I'm going to break this entirely apart. From our prime factorization for 90, I have 2 times 3 times 3 times 5. Okay, now rather than writing out all of these x's, 3 x's and 4 y's and 5 z's, let's just take it and break these apart into evens versus odds, okay? What I'm saying here is x to the third, I could think of that as being x squared times x. And for example, y to the fourth, well, the fourth is an even power, okay? So I'm just going to keep that as y to the fourth. Now, on the other hand, z to the fifth, I'm going to think of that as z to the fourth times z. Now, the reason I'm doing this is because another thing that you can do when you're dealing with square roots, think about it just a little bit here, another thing that you can do is when I take something out, I can basically cut the power in half, okay? So just like I did right over here on this one, let's go to a better example. This one right here. I could have rewritten this problem as the square root of 2 to the fourth times 5, and I take this out because it's an even power and half the power. And as you can see, 2 squared is 4. All right? So I'm going to use that trick right over here in this problem right here. All right, once again, we're going to need to start pulling numbers out. We can see that in this case, 2 is a single 2. So I'm going to leave it. I have a pair of 3's. Cross out a pair, bring out 1. Okay, I've got a single 5. I've got x squared. Well, I'm going to take out those x squares right there and bring out a single x. Okay? Now, we still have another x in there, but we're going to skip right on over. Y to the fourth. Okay, I'm going to bring that out and call it y to the second. And we have a z to the fourth. That could come out and become z to the second. And we have a single z there. It won't come out. So what's left inside of our radical now is the following. I did not cross out the 2. I did not cross out the 5. I did not cross out the x. I did not cross out the z. Okay? So now we'll take a look at what we've got all together. I'm going to put it all together, then we're going to clean up our answer just a little bit. I have 3x y squared z squared, square root 2 times 5 is 10. I have an x and a z. Now, going back to our rules here. Okay? All right. For expressions where the exponent variable inside a radical is even and the simplified exponent is odd, you must take the absolute value. So we can see here that when I'm going back to this one, all right, I don't need to worry about absolute value with x because the original power was odd. Now I'm looking at y. The original power was even. This is even. I do not need to worry about it. Okay. Odd, I do not need to worry about absolute value. Now, if I made one little change to this, and suppose that I called this, let's say we called this y to the 6th, then that would cause this to be y to the 6th, which would cause this to be y to the 3rd, which would cause this to be y to the 3rd. Now, in this case, I have even, odd. Then in that case, I would need to put the absolute values around y to the 3rd. Okay, I believe that is it for today's lesson. I'll be back tomorrow for the second part of this lesson.